Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem next greater element. What does that state? Basically, you will be given an array of n elements. Over here, I have taken an 11 size array. You have to figure out for every element which is the next greater element. Okay. For an example, if you stand at 3 and you look at the right, the next greater element that you will get for 3 is nothing but 10, because 3 for 3 the next greater element is 10. Now, if you stand at 10 and you look at the right, you will not see anyone greater than 10. Okay, you will not see anyone greater than 10. And if you do not see anyone greater than 10 on the right, you will come back and look across here. Do you see anyone from this side? First, you look across this side, you don't find anyone. Then you start looking from this side. Do you find anyone? You don't. So, if you do not find anyone, you'll just write -1 to this guy because there is no next greater element. Let's do it for 4. If I check out for 4 on the right, 2 is not the next greater, 1 is not the next greater, 2 is not the next greater, 6 is not the 6 is the next greater. So 6 will be the next greater. For 2, which is the next greater? 6. For 1, which is the next greater? 2. For 2, which is the next greater? 6. For 6, which is the next greater? 7. For 1, which is the next greater? 7. For the 7, which is the next greater? 9. For 2, which is the next greater? 9. For this 9, I don't see anything on the right. So I'll start from here. Is 3 the next greater of 9? No. Is 10 the next greater of 9? Yes. So for 9, the next greater is 10. So this is how the next greater element will look like. So you have to just print, or you have to return me this NGE array. Yes, you have to return me this NGE array, next greater element array. Now, let's first keep aside a very this is a circular array kind of a problem, right? You have to, if you don't find it on the right, you have to look across from here. That's a circular array kind of problem. First, let's try to solve the easier variant of this problem. What is the easier variant of this problem? It's nothing but I'll try to figure out which is the on the right. I'll just try to figure it on the right. Now, what do I mean by I'll be figuring out on the right? For 9 on the right, there doesn't exist anyone, so I'll print a -1. That means I'll not be considering the circular array question as of now. The first variant that I'll be solving will just look across right, no circular one. We'll just be looking across right, and we will try to solve that problem. And after that, after that, we will try to solve this circular variant because it will be just a minor change. So what will be the brute force? Can I say the brute force will be nothing but for every element from 0 to n minus 1. Yes, for every element from 0 to n minus 1, I can definitely look on the right, and that right will be starting from j equal to I plus 1, and I'll go on till n minus 1. And whichever is a of j is greater than a of I can say that guy will be the next greater element of I, and I can definitely put it. And once I've got the next greater element, I can put a break statement and I'll break out. So this is how the brute force will look like. For every element, I'll look on the right and I'll figure out which is the next greater element. But imagine for an array like this, 10, 6, 7, 5, 3, 1. You will never find a next greater element, and the answer will be -1, -1, -1, -1, because there is no next greater element on the right. So for this kind of a test case, this loop is going to run for a big O of n square, because this is going to run completely, and this is also going to run till n minus 1 because I don't find any next greater element. So the time complexity of the naive solution that you're going to tell to the interviewer will be big O of n square, and obviously the interviewer will not be happy with this, and he'll ask you to optimize this. That is when we will be using stack. Now, why stack and what is the intuition behind it? I'm going to discuss everything, but first I'll tell you the algorithm, and then I'll tell you the intuition behind that algorithm. So let's first understand the algorithm. So before moving to the efficient solution, let me talk about the sponsor of this video. This video is sponsored by Reliable, which is backed up by Unacademy. Now this is India's first hiring tournament platform where you can participate and you can get a chance to work with India's finest startups. So how this works is you have to register in the tournament and you have to participate. Let's say you're in the top 25 percentile of all the participants. You get a chance to interview at all these India's top startups, and if you clear the interviews, you will be handed off with handsome salaried job offers. Now you must be thinking, which startups? So Reliable has partnered with companies like Razorpay, Urban Company, Upgrad, 1MG, Yellow Messenger. Now there are in total of 50 plus companies with 500 job opportunities, basically 8 to 10 openings per company they do have. And what is the CTC offered? The CTC is around 10 to 20 LPA. Now what kind of jobs can you apply for? You can apply for business development, you can apply for front end development, you can apply for back end development. Now the participation in the tournament will just cost you 1999, and if you apply the coupon code Take Forward, it's gonna cost you 1799, and the last date to register is 22nd June. So guys, go check it out and don't miss this opportunity. So the efficient solution will be using stack. So what we'll do is we will define a stack data structure, which will be an empty one initially. Now what is a stack data structure? That is nothing but a last in first out data structure. I've already made some videos on this. You can definitely watch them out if you don't know what is a stack. So what we will do is we will start iterating from the last element. So the last element is nothing but 6, and we will see if there are any elements lesser than 6 on the stack. I see that there are no elements lesser than 6 on the stack. So what I'll do is I will see if there are any elements on the stack. I see no. There is not a greater element also. So I will take -1 and I'll put it over here. Okay, done. Once I've done that, I'll take this 6 and I'll insert that into my stack. Right after that, I'll move my pointer to the next element 4. 4 now checks if there are lesser elements, and it finds that there are no lesser elements. So now 4 says, who is the topmost element in the stack? It says 6. So he'll take 6 and say, okay, since there are no lesser elements on the stack, I take the topmost guy, 6. And that will be my next greater element. After that, he takes this 4 and inserts it into the stack. Right after that, it goes to the next element, that is 2. Again, 2 checks if there are smaller elements on the stack. No, there are no small elements. So 2 will take the topmost element, that is 4, and he will say 4 is my next greater element. And what he will do is he will take this 2 and he'll insert that into the stack. Right after that, you will go to this 1 guy, and again 1 will do the same thing. Are there elements lesser than 1 on the stack? I see that there are no elements. So what it will do is it will take the topmost guy and say it is my next greater element. Fine. After that, it will take that 1 and it will insert it into the stack. If you carefully observe, a pattern has been made. The stack is containing elements from top to bottom in an increasing order. Yes, in an increasing order. You see that pattern forming, right? So after that, when you come to 3, if you want the next greater element, in this increasing order, you need to remove all the smaller elements than 3. So first, 3 compares it with the top. It is small. Remove. Then 3 gets compared with 2. Remove. Since it was an increasing order, you made sure that all the small elements than 3 were removed. Right after that, 3 sees which is the next top element. That's 4, which is greater than 3. Hence, it becomes the next greater element. And this 3 will get into the stack. Now, you might be thinking, hey, Striver, you wrote 3, but you removed 1, 2. This 1, 2 is removed, but it might be an answer for someone else. No, yaar, how can it be an answer? Just imagine if you're looking from this angle on the right, if 3 comes before 1 and 2. So if 3 is coming before 1 and 2, 3 will obviously be the next greater of anyone on the left. 1 and 2 can never be, because 3 is already greater than 1 and 2, right? For this 2, if you look on the right, just imagine this was not, this was something like 1, just imagine. Then for this 2, this 1 and 2 can never be the next greater element. This 3 will only be. That's why 1, 2 have no significance, and you can definitely remove that. So I hope you have understood the intuition of removing 1, 2, because if 3 is there, 1, 2 can never be the next greater element. Okay, so 3 has been inserted. Next, come to 5. Again, do the same thing. It's following an increasing trend. So remove all these smaller elements. 3 will get removed, then 4 will get removed. Right after that, whichever is the element, that will become my next greater element. Again, makes sense. I remove 3. 1 and 2 I previously removed because they can never be the next greater element. So as of now, I have 5's next greater as 6. Take 5 and insert that into your stack. Done. Come to the next guy. 2. 2 sees are there smaller elements, and it sees that there are no smaller elements. So what he will do is, whatever is it at the top, he will take that and he'll say that, okay, this is my next greater element. So I've taken that. Right after that, 2 will get back into the stack. Now let's move. I come across 1. 1 sees that there are no smaller elements, hence it doesn't remove anyone. But 1 sees the top guy to be 2, hence that will become its next greater. And he'll take this 1 and he'll insert that over here. Right after that, you will move to something which is 3. For this 3, again, it's following an increasing fashion. Kindly remove all the small elements. So 1 will be removed, 2 will be removed. So I've removed all the small elements. Now for 3, which is the next great element, 5. So again you write 5. Again, very obvious because for 3, 1 and 2 will never be of any use. So 3's next greater is 5. Take this 3, insert it. Right after that, you come across to something as 5. 5 will remove 3 as well as 5 because it wants the next greater element. For 5, 6 is the next greater element. So you'll take that. Taken. Now take this 5 and now again insert that. So this is how the stack will be now. Let's move to 12. What 12 will do is, 12 will remove all the next greater, all these small elements. 5 is removed, 6 is removed. Apparently, 12 removed all the elements from the stack. Hence, I can say that 12 doesn't have any greater element. That is why stack is empty. I can say -1. And I'll take this 12 and I'll insert that into my stack. Right after that, I'll come to 4. Yes, right after that, I'll come to 4. When I come to 4, I will again look if there are small elements. I don't find any. So I'll take this 12 and I'll say, that's your next greater element. And once I've said that, my pointer will move beyond. Hence, I've traversed from the last to the first, and my next greater element array is ready. That's going to be my answer. So I hope you've understood the intuition while I was explaining. The intuition is very simple. I want to maintain an increasing order so that I can easily remove these smaller elements, right? Because the smaller elements do not have any sense, because if I'm looking on the right, if there is someone as 2x, these x or x by 2 elements will be of no use, because for someone who is x, for this x, this 2x will be the next greater, not these guys, because when he'll travel, he'll find 2x at first. That's why removal of smaller elements is so important over here. So this is how the first variant of the problem can be solved. Now, the original question, let's come back to the original question. The original question stated, you have to also figure out the circular one. Like for 6, the answer will be 12. You have to figure out the circular one. So let's take a smaller array and tell you how to convert this similar logic to the circular array. So this is the example for which we will be implementing the circular variant. Now, in order to solve this circularly, what you will do is, you will just copy paste the same portion once more. So that's going to be 2, 10, 12, 1, 11. Once you have copy pasted it, just solve it as you solved the first variant. Just solve it on the right side. So if I solve it on the right side, for this 2, look on the right, it comes as 10. For this 10, look on the right, comes as 12. For this 12, look on the right, what does it comes? No 1. So it's a -1. For this 1, look on the entire right, this comes as 11. But for the 11, when you look on the right, 12 comes in. So you just need to figure out the answer for the first 5 elements. If you copy paste it twice, automatically for 11, these portions will come at the front and you will be able to solve the problem using the logic that we implemented in the first variant of this problem. Now, how will we actually implement this? Now, in order to implement circular array, you don't have to do anything. It's a very easy thing. If I write the indexing, it's a 0, 1, 2, 3, 4, That's for n equal to 5. The indexing is generally 0, 1, 2, 3, 4. What you will do is, from 0, 1, 2, 3, 4, you will start having 5, 6, 7, 8, 9. You don't have to make this array. There's absolutely no need to make this array. Rather, just iterate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What you will do is, this I, if you do a modulo n, yes, if you do a modulo n, what will happen is, so let's imagine you are at the fifth index. So in order to get this 2, you will just have to do 5 modulo 5, which is the 0th index. You will get the 0th index. Now let's imagine you are at the 6. So 6 is nothing but 10, which is the first index. So 6 modulo 5 will give you the first index. Next, imagine you are at the 7th. So 7 modulo 5 will give you the second index. So it's an imaginary array that you're thinking. Yes, it's an imaginary array that you're thinking. You don't need to create this array, because if you implement I modulo n, you will automatically get 2, 10, 12, 1, 11. You will automatically get all these guys. So it's very simple. From 0 to 2n minus 1 is the index where you have to iterate, and the logic will still stay at the first variant. So let's try to write the code. So imagine I am looking for the answer in the ng array. So I'll have to declare an ng array of size n, correct? And I know one thing for sure. I will also require a stack. So definitely declare a stack of an integer. So I'm declaring these couple of things that will be required. One thing I know, my iteration will go from 0 to twice. So it's going to go till 2n minus 1. So why don't we go till 2n minus 1? Now, what did we do at the first instance? First instance, we removed all these small elements of the stack. If you remember, the stack contains elements in the increasing fashion. So what I'll do is, I'll try to remove all these smaller elements. So if the stack is not empty, if the stack is not empty, then I will remove all the elements that are smaller than, yes, that are smaller than equal to a of I. If the stack is non-empty and the topmost element is smaller than a of I will say, hey, why don't you remove yourself? So I'll remove all these small elements. Once all the smaller elements have been removed, I need to get the topmost element, because that will be my NGE. So I know one thing. I only require the indexes from 0 to n minus 1. That is very much clear, because I've copied the array twice. So what I'll say is, if the index is lesser than n, then only I require the NGE, because beyond the first half, I don't require the NGE. So what I'll say is, if I is lesser than n, and if the stack is not empty, again, if the stack is not empty, then can I say my NGE, yes, my NGE of I is equal to stack dot top, if the stack is not empty. But if the stack is empty, can I say my NGE is minus 1? That's how you can definitely write. And what if this, after this, what? You have to take that element and you have to put it onto the stack. After that, please make sure you have to take that element and you have to put it onto the stack. So this is how your code for the first variant would have looked like. But I did tell you that everywhere, yes, everywhere, since you're implementing circular array, please make sure instead of I, you have to write I modulo n, obviously over there, and obviously over here you have to write I modulo n, so that you can directly access the first half without actually making a copy of it. So this is how you can implement your NGE. Now, what will be the time complexity of this one? I can say the time complexity is bgo of 2n plus a bgo of 2n. Now, why a bgo of 2n? Why not n square? Okay, let me just ask you a very simple question. This loop is running for 2n times. Everyone knows that. But is this loop running always for 2n times? Ask yourself. And the answer that will come is no. Because sometime this might run for 1 time, it might remove one small element, sometime it might run for 2 times, sometime it might run for 0 times, sometime it might run for 3 times. Overall, throughout the iteration, like how many times is this while loop executed throughout the for loop? What will be the total number of iterations this while loop will be executed? If you think, won't it be the total number of elements of the array? Because those elements are getting in and those elements are getting out, isn't it? Hence, the total iteration across the for loop will be 2n of while loop. If you did not understand, I will just give you a very simple hint. While you code, just try to put a count plus plus count over here. Or you can definitely write cout to count how many times is this while loop is executed. Then you'll get a better idea. This is how you generally try to get a better idea. Just because this while loop is not always running, and throughout someday it might throw 1, 2, 0, or 3 elements, throughout it will be running for 2n elements. So that is why the time complexity can be written as a big O of n solution. I can approximate that. And the space complexity will be a stack, and this one is for answer. So we generally do not compute anything which is required to store the answer. So I can again say it's near about a big O of 2n or n solutions. So that is the time complexity as well as the space complexity for finding next greater element. I hope you can do both the variants now. If the first variant question comes, just make this n minus 1, and the second variant circular array question comes, make it 2n minus 1. Both of the solutions are going to work. By the way, I'll be leaving the C++ code as well as the Java code link in the description. So guys, I hope you've understood the entire explanation. Just in case you did, please make sure you like this video. And if you're new to our channel, do consider subscribing. And with this, bye-bye, take care, stay safe.
Whenever your heart is broken